So in 6.3, we start talking about sampling distributions. And the best way to approach this is to think about us starting to bridge the gap between our knowledge of descriptive statistics and probability. So our hope is that in learning how to work with probability distributions, we're better equipped to make inferences and make statements predicting how likely certain events are related to random sampling. So in the simulation, which comes from Online Statbook and a free online resource, open source, and we're going to use the simulation to look at what happens to statistics when we think of statistics as random variables. So the statistics that we explored in Chapter 3, such as mean, proportion, standard deviation, variance, all of the above, those all are connected to sample data. We have a sample data distribution. We compute these statistics for each sample, but we can take repeated samples independently of each other from a same population, and we'll see what that does to the repeated statistics that we take. So as an illustration here, I have this parent population, which we assume is normal. So it's a normal distribution, and from this distribution, we're going to be taking some samples. So I'll first just take 5 sample data points. So what we're looking at here then is we have taken a sample, and we have taken 5 samples, and in each of these samples, we have also computed the means. Let's maybe see this animated. So we've now done a single sample of 5 sample size, and once we had that, we've computed the mean, which gets added to the distribution of means. Let's see that again. So 5 data points are taken, and then the mean is collected and put in the distribution. If we do this many, many times, say we take 10,000 random samples of the same sample size, then we get this distribution. You'll notice that the expected value of the means is almost in line with the mean of the original distribution, and it's got the same kind of shape. It's got a bell curve shape. Just the peak is, it's centered in the same place, but the spread is slightly lower than the parent distribution. And if we do that again, it just keeps getting closer and closer to this bell curve shape, and we get that the standard deviation is smaller than the parent population. So what happens then if we clear everything? But instead of taking means, we could take standard deviations, and we'll pick, say, larger sample sizes, like 25. So we take samples of 25 randomly selected data values, and for each sample, we compute a standard deviation. So here are our 25 data values being collected, and those are being arranged on a histogram. This, in the long run, should end up looking like the parent population, but now we've calculated the standard deviation, and we got just this one value here. If we do this 10,000 times, we get this very, very tight distribution. So it looks almost like maybe it's bell curve shape, maybe not. We'll do it again. And again, and again, and again. So now we have just over 400,000 samples of sample size 25. And you'll notice that these have a much lower mean because these are standard deviations. These are means of the standard deviations. And the the spread of this distribution is very, very tight. Do you think that maybe this changes if we're looking at a different kind of parent population? Because we were taking things from a normal distribution. But let's try now a uniform distribution, and let's see what happens with the standard deviation with a sample size of 10. So again, we take 10 values at random from this distribution, and we find the standard deviation. Let's do this 10,000 times. Wow, so that's different. The standard deviation is now a little higher, and the spread is larger. So the variation of this distribution is larger. Do you think that this might be different if we look at another statistic? Let's look at the mean again. What happens if we take 10,000 samples? Then this is the distribution of the means, and we again see a bell curve shape, even though the original distribution wasn't bell curve shaped. This is actually illustrative of a lot of really cool consequences that come from sampling distributions, and it's our goal now in this section to explore those different kinds of sampling distributions.